First, we will add a manual trigger so that we can start it by clicking while we develop. Next, we will set up some variables which we will reference throughout our workflow. This will help to make our workflow reusable in the future. We are going to be adding a supplier ID which matches an existing supplier in the retailer's SQL database. We will set this variable type as a number in our supplier ID, which is number 4. We're also going to be adding a number field called stock item template ID. This will represent a similar existing product in our retailer database that we will use to populate the required fields not provided in our supplier CSV, including price and tax information. It is a good practice to always give your nodes relevant names because you may need to refer to them later on in the workflow. We will add a read and write files from disk node to read the supplier's CSV file. We set the file selector path, which includes the supplier ID variable we set in a previous step, as part of the path. When we execute this node, we can see our output is the supplier's CSV file in binary format. Because our supplier file is in binary format, we must add a node to read the binary file into CSV format. If we execute this node, we will see that the contents are extracted. However, the delimiter in our file is the pipe character, and the default for the node is a comma. This is not a problem, as we can set our delimiter to any character we choose. Now when we execute the node, we can see our data is formatted as expected. We can also see that the JSON data has been extracted in the expected format. Because our next task, reading the size mapping CSV file, is similar to reading the supplier CSV file, we can just duplicate our nodes for the supplier CSV and edit the applicable parameters. We will set the file selector parameter to the path of our retailer's size map file. Again, we will make sure that we give our nodes names with contextual meaning. Because our CSV files use the same delimiter, we do not need to edit any parameters in our extract mapping file node. We will now attach our read mappings file operation to the set parameters node. Next, we will add a node to get a list of the retailer's predefined colors from the SQL Server database. We will be adding a Microsoft SQL Server node and setting the operation to execute a query. We will connect the SQL Server node to the set parameters node. We will set our query to select the color ID and color name from the colors table in the warehouse schema. After executing our node, we can now see that we have our color records in the expected JSON format with the color ID and color name. Next, we will add another SQL Server node with an execute query operation in order to retrieve the default values for new products. We will attach our new node to the set parameters node. We set our query to return field values we will assign to new products inserted into the database. This will select a single record representing a similar product which already exists to apply the same values to the required fields not included in the supplier's CSV file. In order to determine whether we will be inserting or updating products, we will need to get a list of existing products for the supplier. We will add another SQL Server node and attach it to the set parameters node. We set our query to select the stock item name that we will use to match products. The current quantity so that we can add this value to the quantity for existing products, and the stock item ID, which will be used as the key in our update statements. We also want to select only records that match our supplier ID, which is the value of the supplier ID parameter we set as the first step in the workflow. As mentioned in the introduction, our supplier CSV data does not align with the retailer's database. The sizes in our supplier file do not match the defined sizes in our database. We also need to match the color names in the supplier's file to color IDs in the database. Additionally, our retailer uses a product name that includes the color and size description, where our supplier uses only the product name, so the product name value will need to be transformed. If we look at our supplier file, we see that the sizes are spelled out using the full name of the size. Our mappings file will be used to map the supplier's size specification, the full name, to what is required in our retailer's database, abbreviations for sizes, capitalized. In order to do this, we will need to map values from both the supplier and size mapping file. We will match the size from the supplier's file to key in the mapping file. We do this by adding a merge node. We will connect the supplier file to our first input in the merge node and our mapping file to the second input. We will match the field name, size, from the supplier file to the size key field in the mapping file. This will give us a combination of both records, which includes the size value field, which aligns with expected values in the database. Next, we will handle our color mappings. In order to do this, we will add another merge node, with the output from our size merge node as the first input to the new merge node. We connect the output from our database colors query as the second input to our merge node. We use the merge combine operation and map the color value in the supplier's file to the color name value from the colors database query. This will give us the color ID in our output to use for our new product insert statements, which require a valid color ID instead of a color name. As previously mentioned, the supplier and the retailer use different product naming conventions. The retailer appends color and size information in the product name. We will add an edit fields node for this task. In order to format the supplier's product name to the specifications of the retailer, we will be combining the product name, a hyphen character, and the color abbreviation in parentheses. The formatted name will be set in our field value expression by combining properties from our previous node's output and adding applicable characters to the output format. We add a new field called formatted product name and set the node to include other input fields so that we will have the full record. In our output, we now see the formatted product name included in our JSON, along with the mappings from previous nodes. Now that we have product names that match the retailer's specification, we can use this value to determine whether a supplier's product is a new product, hence an insert, or an existing product, an update. To do this, we will add another merge node with input 1 connected to the output from our product name transformation and output 2 connected to the result of our retailer products query. We will use a combine operation to match our formatted product name value from the previous node's output to the stock item name from the products database query. We want to set our output type to keep everything, as we also want to keep products that do not match as they represent new products. For existing items, the stock item name, stock item ID, and quantity will have values. For products that do not exist in the database, these properties will not exist in the output JSON. Now that we have a combined set of supplier and existing products, we will need to determine whether or not the record should be an insert or an update. To do this, we use filter nodes. We will add a filter node for our inserts and attach the output of the merge existing products node as our input. In our filter expression, we assign the condition stock item ID does not exist. If there is no stock item ID, then there were no products matched by names, so they are all inserts. Because we have 12 records in our supplier's file, and they are all new products, we expect the same amount of output records, 12. We can see in our output pane that indeed 12 records were kept, matched, and 75 records were discarded, not matched because these were existing products with a stock item ID. We will now add another filter node for our updates. Because our existing records merge contains both matches with existing products and non-matches from the suppliers file, records from this set that have both a stock item ID from the database and a formatted product name from the suppliers file represent existing records. We set our filter conditions to include only records where both stock item ID and formatted product name exist. These will be our updates. When we execute this step, we can see no records are kept. This makes sense as our insert filter returned 12 records, the same number of product records in the suppliers file. Because we have not run the ETL process yet, all of the products will be new records. To handle our inserts, we will add a new SQL Server node with our insert filter as the input. For our insert, we will be using a stored procedure which adds new records to the retailer's database. Our parameters will be set using values from nodes we have created throughout the workflow. We map our supplier ID using the set parameters node and our get product default template from database node for the values we want to apply not included in our supplier's CSV file. We map our quantity, product name, and color ID from the output of our previous filter node. We will add a SQL Server node for our updates, with the output from our update filter as the input. For our updates, we will use a SQL statement which declares the parameters we will need to update our record. We select the values into these variables using the stock item ID for the existing product. The only value we will be updating is the quantity. To do this, we use an expression to add the current product quantity to the quantity value from our supplier's CSV file for the matching product. We are now ready to execute our workflow, so let's go ahead and do that. Our workflow executed successfully. Notice that only the Execute Inserts node was executed because there were no product records for updates. The suppliers file contained all new products. We can see that the Execute Inserts node was executed for 12 items, the same number of products in our suppliers file. We have just imported all 12 records from the supplier's CSV file into the database. If we run this workflow again, we will see that our Execute Updates node is triggered, while our Execute Inserts node is bypassed. Our workflow was executed successfully. We can see that the Execute Updates node was triggered for 12 items. To verify our workflow is updating the retailer's database correctly, we will select the new products in Microsoft SQL Server Management Studio. We see 12 new products that did not exist before our first workflow execution, so the Execute Inserts node worked as expected. Note the highlighted quantities. Because our Execute Updates node add the quantity in the supplier's CSV file to the existing quantity for the product, subsequent workflow executions should update these quantity values. Our first record has a quantity of 10 in the supplier's CSV file. We executed our workflow twice. The first execution inserted the records. The second updated the records, adding the supplier quantity to the existing quantity in the database. For our first record, the initial quantity was 10, and once the record existed and the update was run, the quantity in the supplier's CSV file was added to this. Hence, the quantity is now 20. After running the workflow for the third time, we can verify that first record's quantity has been updated again by 10. This is what we expect. Our workflow is running the ETL operation successfully. This demonstration showed how n8n can be leveraged to perform ETL operations that are easy to visualize, design, and maintain. In a production scenario, there would be other considerations including optimization, appropriate sequencing, error handling, and other details which were not demonstrated in order to keep focus on the main points. However, with a thorough understanding of your data and some creativity, you can achieve solutions to your data transformations using n8n with rapidity and ease, bringing a strong and highly capable toolset to your organization.